I'm Allison Singer with the Autism Science Foundation, here today with Dr. Bob Schultz. He's the director of the Center for Autism Research at the Children's Hospital of Philadelphia. Bob, thanks so much for joining us today.
Thanks for having me.
So, Bob, you have been in Philadelphia since 2007,
Right.
when there was no Center for Autism Research, and you basically built this center from the ground up. It's really remarkable when you look back just a few years at how much you've accomplished. What are you most proud of?
Well, I think we've pulled together just an outstanding team of scientists going from basic science, genetics, animal models, some of them you've heard from today, all the way through to people who study the characteristics of autism and then actually how to intervene and develop and test new treatments. So I think it's the entire package, and it's the kind of the critical mass that we can ask almost any question at any level, and we have experts here who can address that, and that we can play off of one another. So when we learn about a gene, we can ask immediately questions: what does that gene have to do with, say, a treatment, or what does it have to do with a finding in brain imaging? So it's that critical mass which I think I'm most proud of.
And what is the mission of the center?
So the mission is really three parts. First and foremost, we want to understand what causes autism. What are really the causal mechanisms? Because while we recognize there are effective treatments today, there's really a long way to go. And we don't think we're going to be able to solve the riddle of autism until we have a much more detailed understanding of the biology. What are those mechanisms, and how can we create better treatments? But along with that, we need to do something in the near term. Families are struggling, and so we really want to be a resource to the community. So we see hundreds of kids per year in different research protocols, and we want to give back as much as possible. So part of that is doing detailed evaluations of the kids, which we need to do anyway for our studies. If you're going to measure the phenomenon, you have to do it in detail, and that can be enormously helpful to the families to get that kind of feedback. So we give automatically verbal feedback and written feedback. And as part of that, the third part of the mission is actually to train the next generation of scientists. It's a big problem understanding autism, and we need a bigger workforce. And so we integrate trainees into every level of what we do.
What are some of the other benefits of having a large cross-disciplinary team?
So one of the things that all autism researchers struggle with is both recruitment, finding children for studies, and also the heterogeneity. There's this saying, if you've seen one child with autism, you've seen one child with autism. So we're faced with this dilemma that when we study kids with autism, we don't really know how to group them together. And so most labs now are trying to accumulate large samples. So one of the things that we've prioritized at our center is to get a very large clinical research group. So we actually have 10 clinical PhD psychologists available to do the initial diagnosis and phenotyping of these kids. And we actually have a large recruitment team as well. So we have 3 or 4 people who all they do all day long is attend events or in one way or the other try to recruit families and explain to them the benefits of doing research.
Now, your research specifically focuses on imaging. What is the role of imaging? Where does it fit in the puzzle of how we learn about autism?
It fits squarely in the middle. I'm always fond of saying we want to study the relationships between genes, brain, and behavior, and it really is the brain which is the immediate mediator of the behavior, and genes are kind of the ultimate cause of the behavior, but they act through the brain. And so I think what is interesting about our research is that everyone we bring into our studies, we try to get good information at all 3 levels. We try to get information on genetic risk factors, brain, and behavior. Some of the tangible reasons that imaging is important is we can identify mechanisms at the level of brain systems. Lots of things can be going on in the brain, and we want to say, well, what kinds of things are the most important for the problems that kids with autism face? So we can hone on certain systems. We can look at certain ways in which the brain is active or is organized. But we can also use that information to make predictions. And there are 2 kinds of predictions I'd like to mention. One is early in development. We know that autism evolves really in the 2nd year of life. We've tried to find early markers, and there's hints of early markers at the behavioral level, but by and large, you can really see autism evolve in the 2nd year of life. To me, that's always a hopeful sign. I actually am happy that we struggle to find behavioral symptoms in the 1st year of life, because it might mean that there's a period of at least a year of more typical or normal brain development, in which case we have an opportunity to intervene. But we like to use imaging, and I'm part of a national network known as IBIS, or Infant Brain Imaging Network, that wants to find biological markers to make predictions earlier than we can based on behavior. And if we can make those predictions, then we can start kids in intervention programs earlier. And it'll be a hint as to what the earliest manifestations at the level of biology are. So when we do brain imaging later in life at 10 or 15 or whatever age, you're never quite sure if you're seeing the earliest causes of autism or whether you're seeing an effect of having autism. Because a child with autism will have a lot of different kinds of experiences. They'll structure their environment around what interests them, and that could cause a different developmental trajectory. So I think it's really important to study the brain early. Second, we also are very interested in using imaging as perhaps a more sensitive marker and an earlier marker of effective intervention. So behavioral measures are great, and ultimately they're the most important, but that measurement might not be as quantitative and as precise. And something closer to the root of the behavior, the brain itself, could ultimately be more sensitive as a measure of treatment change.
So you're talking about treatment response. Is there a role for imaging in terms of developing new treatments? I mean, can we take what we've learned through the imaging and use that to improve existing treatments or develop new ones?
Sure, we can. I mean, I think imaging teaches us, it's a complement to behavior. So any given behavior might seem like a single entity, but if you look at imaging, you might say, oh, it actually breaks down into 3 or 4 different processes. And although we're targeting that behavior at a single entity, it might be smarter to break it down into its subcomponents and say, well, if we just pushed on this, things might get better. So for example, we're very much interested in understanding motivation and learning, so reward processes. And we believe that some children with autism have deficiencies in social motivation, and that could cause a lot of downstream consequences. So if you're not motivated or you don't find interacting with individuals, other people pleasurable, you probably fail to learn a lot of social signals. You don't read social cues as well because you've spent actually less time on task. And if you don't read social cues, it's hard to have active or accurate models of other people's minds. So we think there could be a chain there. So we could intervene and try to teach kids theory of mind, or we could intervene and try to teach kids about reading social cues. But maybe if you intervene at the base and say, I'm going to change social motivation, all these other things will happen more naturally. You'll kind of release a potential that the child already has.
I think sometimes parents have confusion about what it means to participate in an imaging study. Right. Can you describe a little bit about the experience for a child who's participating in an imaging study?
Sure. We take a lot of care to make sure that children are comfortable in imaging studies. First, we should say that the kind of imaging we do, we by and large use MRI, but as you'll hear from our colleague Tim Roberts, we also use other techniques such as MEG, we might use EEG or ERPs. All of these parents should know are safe. They're non-invasive. They don't involve any kind of what we call ionizing radiation, which is the basis of an X-ray. So there's no known danger to any of these things. Second, we have a pretend MRI right here in the center. So one of the first things we do when a child comes into a study is we get to know the child, we'll do a little bit of assessment, but then we spend a great deal of time actually playing inside the mock scanner, where we get them to get the child to be comfortable with it. They lie inside, they get to experience what it means to be inside of a confined space, understand what it means to hear the sounds of an MRI machine. And a difficult thing for the child is when we say, you know, when you're getting that picture of your brain taken, you can't move, or you can't move too much. That too much is a hard concept, and so we get to actually practice what too much means by teaching them if they move too much, something will happen. In this case, we train them if they move too much, a video that they have chosen will actually turn off. So we can shape their behavior.
I want to thank you for being here today. And again, I want to congratulate you on what you've built here. It's truly a great resource for families in Philadelphia. So thank you.
Well, thank you. Appreciate it.